Today we're talking about proving triangles similar again. How did we prove them similar yesterday?
Using,
it was like angle side. Something like angle.
Angle. So yesterday we used angle similarity. Yeah, that was yesterday. Angle similarity was 6.4. So today and tomorrow we're going to talk about two more ways, which would be side similarity and side angle similarity. Now remember yesterday I started adding the little squiggly, the similarity symbol after angle. I will also highly recommend you do that with side and side angle side. This is different from when we used SSS and SAS for congruence. Different theorems. They will look familiar and they'll look kind of the same, but you'll have at least one word that is different to distinguish them. Well, a couple words. Okay, determine if the triangles are similar. What do you think about number one? No, they would not be similar. They only have one pair of congruent angles. The second pair they gave us is not congruent, which means... Oh, does that mean? Oh, let's hold on. I'm not committed to that yet. I was feeling committed, and now I'm not so sure. So let's draw those triangles out. Yeah, Taylor, what did I realize?
You have to add the angles together and then subtract from 180.
Good.
And you should get two angles that are the same.
Good. So if I know right now that these are my angle measures, I can find my last angle measure by adding the two that I have together and subtracting from 180. And so I should get that this last angle is 46 degrees in this one. So based on what it initially looks like, I thought it was a no. Bless you. But then once I found one of my missing angles, I suddenly realized that it's a yes. Yes. So we changed our mind. Okay, just because you're given two angles doesn't mean you shouldn't check the last one. So on number two, we won't jump the gun again. Let's look at least one of our triangles. I'm going to look at the one with the 90 degrees because I think that one's easier. Okay, I know I've got two angles that match. What's my last angle going to be for my bottom triangle? 66. Are we all okay with that? Okay, so if I know that three of my angles in one triangle are 90, 24, and 66, am I going to be able to get that to match up with my other triangle? No, because my other one's 24 and 132 and something else. So neither of these other angles match the 132. It's not going to work out. So I checked it, I tried, but no, it's not going to happen. Questions, concerns about the warm-ups? Warm, fuzzy feelings. I mean, they are warm-ups, so. Ready to go on? Okay. Side similarity theorem. Notice the similarity squiggle. If corresponding side lengths of two triangles are proportional, then the triangles are similar. So remember last semester when we saw SSS, all the side lengths were congruent and the triangles were congruent. So these are the words that change. Instead of congruent, we're just looking for proportional. Instead of congruent triangles, we're just showing that they are similar. So let's write this out in symbols for these triangles. So if I'm going to make a big old proportionality statement, then I'll be able to make a triangle similarity statement. So if, let's start with side AB, that would have to get compared to what side from the other triangle? RS. If AB to RS is equal to, let's go BC to ST is proportional to AC to RT. If that's true, all the side ratios are proportional to each other, or the ratios are equal, sides are proportional, then we can say that triangle ABC is similar to triangle RST. There's really nothing to mark in the diagram. We should not be putting little tick marks on these sides, even though we paired them up, because they are not necessarily congruent, just proportional. There's no symbol to mark proportional sides. We just have to make a statement. Questions, concerns? Need more time on this theorem? Ready to keep going? On we go. Is either triangle DEF or triangle GHJ similar to triangle ABC? Show work to justify yes or no. So if we know we're starting with triangle ABC, let's pick another triangle to start with. So let's go with DEF. So for now, I'm going to just focus on those two. So on the board, I'm going to take away the third one just so we're not tempted to use it. We'll bring it back in a minute, so don't actually cross it off on your page. When you're trying to decide if these triangles are similar, obviously we're using side, side, side similarity right now. Why couldn't we use angle, angle like we did yesterday? We don't know the angles, so that's not even an option. When you check this, you're going to match up sides with each other. As you can see, the triangles are not necessarily oriented the same way. So I would recommend starting with your smallest sides. Meaning from triangle ABC, what side would I start with? 8. If that's the smallest side of ABC, I better compare that to the smallest side of DEF, which would be 4. That simplifies to be 2 over 1. Remember, these are still ratios. They should still have 2 numbers. Okay? So then we move on to another pair of sides. What's the next smallest side from triangle ABC? 9. That would get compared to the next smallest side from DEF. 6. What does 9 over 6 simplify to be? 3 over 2. Do we need to go ahead and talk about the third pair of sides? No, why not? Okay, it doesn't really matter because these are already not proportional. We did not get the same ratio. So that would mean that for triangle DEF, the answer is going to be a no. This is our work that justifies it. If you want, you could go ahead and match up the 12 with the 8 and simplify it. But you don't need to. If we already have a pair of ratios that don't match, it's not proportional. Questions about triangle DEF before we bring back triangle GHJ? Okay. Let's bring back this one, and I will take away DEF so that we're not tempted to use any of that. So again, I'll just kind of split this up to show my work for the other triangle. let's bring back that side too. So for triangle ABC, again, I'd recommend starting with your smallest side, which is still 8, and compare that to the smallest side of the other triangle, which is 16. Thank you. So remember that even though these kind of look like they're oriented the same way, you need to match up small with small. So the 8 gets matched up with the 16, not the 18. Okay, small with small. Reduces to be 1/2, 1/2. The next smallest side from ABC was 9. That gets matched up with 18. Remember, middle length, middle length. I don't care how they're oriented. I care about smallest to smallest, biggest to biggest, middle to middle. Do we have questions about why I keep saying that? No. Okay. 9/18 reduces to 1/2. Biggest side from ABC is 12, gets compared to 24, reduces to 1/2. So, is triangle ABC similar to triangle GHJ? We would say yes. So for triangle GHJ, it's a yes. Questions about how we showed that? Again, we got the same ratio every time. That means that all pairs of sides are proportional. All right, we'll move on to example 2. Which of the 3 triangles are similar, if any? So there is a little bit of work to show here. You got to pick 2 triangles to start with. So I lean towards just starting with the left 2 triangles. Same process. Compare small to small, middle to middle, big to big. But anytime we end up with ratios that are not equal, we can stop, because one that doesn't work means the whole thing doesn't work. So let's start with triangle EDF. The smallest side is 38. Smallest side of triangle GHJ is 30. Simplifies to be 19/15. Okay, we have to at least do one more ratio. So the next biggest side, or next smallest side, middle side, compares to 45. Not 45, sorry, 35. I don't know if that was, I heard you wrong. Or so middle length here is 38, middle one here is 35. We can reduce that. We could divide by 7. What do we get? Do we need to do the last pair? No. So we definitely know that DEF and GJH or HJG, whatever, those 2 are definitely not similar. If you want to, for the sake of this problem, label these as like this is triangle X, this is triangle Y, and label the last one triangle Z, just to keep them straight. This was X to Y, so X is not similar to Y. We tried those 2. Which 2 do you want to try next? X to Z? Okay. So let's leave that alone. Now we'll compare X to Z, so I'll ignore the one in the middle. Smallest side of X was 38. Smallest side of triangle Z is 18. That reduces to 19/9. Okay, next smallest side of triangle X was 42. Compare that to 21. So remember, middle, meaning like the middle number Not the biggest, but not the smallest. Somewhere in the middle. 42 to 21 simplifies to be... What did we get? 2 over 1. So remember the 42 was on top, bigger number on top. So do we need to do the last pair? No. So we definitely know x is not similar to z. So the last two that we have to compare would be y and z. Smallest side of y compared to 18 simplifies to be sure, but that can go further.
5 to 3.
5 over 3, okay. The next side for triangle y is the 35 compared to 21, right? Divide by 7, we again get 5 over 3. So do we need to do the last pair? No. Yes, side says that all of them have to be proportional. So the last ones we stopped because we already had 2 that didn't match. Just because 2 of them do match doesn't mean that the last one will for sure. So if you're going to use side, you better check all 3. So my biggest side of triangle y compared to reduces to 5 over 3. So it does work, but if you're going to say yes, you by side, you better use all the pairs of sides. So instead of calling them y and x, let's actually name them by their letters or their points, vertices. How do you want to name the first triangle? Somebody a little louder. What'd you say, Kira? JHG. Okay, I don't really care how you name the first one, but then your second one better be named correctly to match up with it. Meaning, JH was our smallest side, so we better list our smallest side first here, which would be... We gotta be a little careful about how we go it. I think we need to go KL in this case. KLM. So angle J was in between our smallest side and our biggest side. Angle K was between our smallest side and our biggest side. So that will be one of the tricky parts about using side. When we use angle, it's pretty easy to match up the angles. When you don't know the angles, it's a little bit trickier. Questions about why it has to be KLM and not a LKM? Warm, fuzzy feelings? Ready to try another one? Maybe, kind of, sort of. Okay. Find the value of x that makes triangle ABC similar to triangle DEF. So we're trying to force it to happen. If they give us a similarity statement, that makes our life a little bit easier. You don't necessarily have to do this, but I'm going to just for the sake of our learning. If this is the similarity statement they give us, that means they're matching side AB up with what side? DE. They are matching side BC up with EF, and they are matching AC up with DF. Okay, are we all understanding how we pull that out of our similarity statement? Okay. So, I'm not saying you have to do this every time or show this, but I think it can be helpful so that way we don't get things mixed up. Because right now, we don't know smallest to smallest, biggest to biggest if we don't have X. We don't really know what all the sides are. We might think they look a certain way, but you better not make any assumptions. So let's just start filling this in and see where we get. What is AB labeled? Okay, and DE is 20. What about BC? 4, EF, 10. Let's go ahead and set up the last one. What is AC? 10 compared to DF, 2x plus 3. So you should be able to use either the front two ratios together or the back two together. And we should get the same answer for x either way. So let's go ahead and just use the front two together. If we use those two together and we cross multiply, what do we get? 10x minus 30 equals 80. To solve it, we would add 30. 10x equals 110, which means x equals 11. Just for fun, let's see if it works out the same the other way. So if we were to instead, let's use a different color box. Instead, let's take the back two, and if we cross multiply those, what do we get? Eight x plus 12 equals 100. And then we would subtract the 12, 8x equals 88, which means x again equals 11. So I would not require that you show both of them. You would really just need to do one of them, but I wanted to let you know that you have options. And if you weren't to get the same thing both times, then something went wrong. Questions, concerns? Confusion, warm fuzzy feelings. Some people need to work on opening their eyeballs up a little bit more. Okay. I think I might want to stop notes there.